The first part of chapter 9 is center of mass. And I normally cover it last in chapter 9 because it makes more sense to cover it that way after we've covered momentum. And center of mass is basically saying we got a system here and we want to find where's the center of action. So, in other words, if I had a very large thing here and a very small thing here, and they're connected to each other, then obviously I can push on this thing, but it's this thing, the big thing has more of an impact. In other words, you can think of the moon going around the earth. It's that does that instead of this. Now, really, it doesn't do either one. Really, there's a center between the two, and the Earth actually wobbles a little bit around that center. The moon goes around. Now, the Earth is much, much bigger than the moon, so it wobbles around that center, but that actually explains something. The center is right there between the Earth Moon system, so it wobbles around there. So you can think of the outside of the Earth being going out and the inside like this. That's why you get two tides every day. Everybody knows you get a tide on the side of the Earth facing the moon because, after all, the moon's pulling on it. Why do you get a tide on the opposite side when the moon's directly opposite you? Well, that's because Earth is sloshing around. You can think of it almost like centrifugal force pushing out right there. So, center of mass turns out to be an important concept. So, how do we find the center of mass here? If we've got multiple objects, M1, M2, M3, and they're all different. It's not going to be the center, the geographical center, the geometric center. What we do is we do a weighted average, where the biggest mass counts more than the smallest mass. So what we would do is I'd put an origin somewhere and say this is x1, that's x2, that's x3. And so I do a weighted average. I'd say the x position, center of mass, is going to be m1x1 plus m2x2 plus m3x3, where the bigger mass counts more, the smallest mass counts less. Now the problem is, obviously we have a problem because the units aren't working out right. So you have to divide by all that mass, m1 plus m2 plus m3. So this would be a way of figuring the center of mass. So let's do a couple of examples here. Let's say, for example, that we've got Pluto and its moon Charon. Okay, so Pluto has a mass of 1.3 times 10 to the 22nd kilograms. Charon has a mass of 1.9 times 10 to the 21 kilograms. And the distance between the two is 19,640 kilometers. Okay, and so I want to know where's the center of mass. Okay, so we want to find the center of mass of this. Well, what do we do? Well, we just had the idea there. The x position, the center of mass, is going to be basically the sum of the m sub I, x sub i's over the total mass. In other words, it'll be m1x1 plus m2x2 over m1 plus m2. So I'm going to put my origin right here on Pluto. Okay, and so that means that x of Pluto is going to be 0. Okay, so in other words, this would be the x center of mass is going to be the x of the center of mass is going to be the x of Pluto, mass of Pluto, or mass of Pluto times the x of Pluto, plus the mass of Charon, x of Charon, divided by the total mass. But if I put an origin on Pluto, the x position there is 0. So the center of mass is just going to be the mass of Charon, which is 1.9 times 10 to the 21 kilograms. times the distance, which would be 19,640 kilometers, and then you divide by the total mass, 1.3 times 10 to the 22 kilograms plus 1.9 times 10 to the 21 kilograms. So the x position here is going to be equal to about 2,500 kilometers. Okay, now that's interesting because if you get Pluto and Charon, then the x position, the center of mass is 2,500 kilometers from the center of Pluto, but Pluto actually has a radius of only 1150 kilometers. Pluto is tiny. Pluto is very tiny. It's about the size of Texas, between Texas and Alaska in size. That's why it doesn't really count as a planet. But that means the center of mass is out here above the surface of Pluto. So that means that Pluto and its center of mass, either Pluto and its moon, both orbit around that center of mass. It's really not the moon's orbiting around Pluto. It's both of them are orbiting around some point between the two. So it's really not like a planet and moon. It's more like a binary something, okay, and a binary dwarf planet or something. And so it's not a planet and a moon system, kind of like Earth and Moon is.